you so much and welcome. Today we are going to talk about the keychain. The topic is Keychain Unlock, Mastering Advanced Security for Smarter and Safer Apps. My name is Topchii and I'm an iOS developer or Apple platforms developer. I worked on multiple apps, libraries. Of course, you can find me on GitHub and all of those links. Feel free to screenshot that or take a snapshot and contact me later regarding any questions of the keychain you can have later. And we of course have the Slack channel where I'll be answering all of the related Q&A questions because I'm expecting there to be many. I work at a company called Raketitiede. It's a Finnish company in Helsinki and we focus on consulting and different projects, and this is including iOS development of course, and some of these things that I'll mention will be actually being done as the part of the work. Let's get started. The Keychain Unlock. Before we start, please raise hands to see who of you have used the keychain in your apps. I'm not surprised to see pretty much everyone, and still keep your hands. Keep your hands who use keychain, and who use Keychain API directly. Lower your hands if you use some library or a third-party wrapper if you call the keychain directly. Actually, quite many hands. It's quite surprising and it's great. So I think the keychain is probably one of those APIs that everyone uses, but everyone uses just a little bit. So if we look at all those top apps in the App Store, probably all of them or 90% will be using keychain in there to store secrets. And one of the use cases that are used very often is to store the app settings, configuration files and tokens, for example. And if you're doing just that, using keychain for that specific purpose, there's just new library dropped out of Apple and it's called Swift Configuration. And in my opinion, that's a better choice, so check it out. It dropped really a week ago, and I think for the majority of the use cases, it's a better choice when you do not need advanced security for the keychain, because it's much easier to work with. But today we are talking about the advanced stuff. It's how we store and retrieve data, what is the keychain sharing between multiple apps and extensions, and we'll look into the biometric authentication and how we can harden the security of the keychain to make it even more secure. And let's recap. It's a framework that is mainly used to store sensitive data. It's a C-based API, exposed as a C-only API to the developers, and it's backed by SQLite and handles encryption, decryption in the background, so you don't really work with the cryptography that much. It's the keychain doing it for you. And lots of things are integrated with the keychain: biometry, keychain sharing, as I said, and passcode protection. This is the diagram, how it looks like, and today we're just scratching the surface, unfortunately. We're focusing on these two things. And let's take a look at the Keychain API. The query, if you would query keychain directly, it would look something like this. It looks complex, but in fact, if we break it down into multiple specific segments, it becomes a bit clearer. So the reason for this complexity is it's a procedural programming paradigm. And there are lots of cons. And it's low level, you have to spell everything you want to do. There is no encapsulation, you're passing around dictionaries, you don't know the data types. On the other hand, there are lots of pros. It's very flexible. You can create bindings for your specific use case, tailored to your use case specifically, and you can even go as far as create a keychain wrapper for your specific domain, and that's what we're going to do. It is Turing complete, of course. Swift is a Turing complete language, and you can. This means that it doesn't matter that the API is so difficult to work with. We can mold it into the way we want it to be. And this is actually happening very often. Lots of people, as we've seen here, use Keychain with libraries. There are lots of libraries available on GitHub. And let's build one on stage right now. Let's get back to our query. It looks again quite complex, but let's break it down. As I said, when we break it down, it's actually very, very simple under the hood. The first part is the query configuration. We ask Keychain what we want to do, in what format data do we want to receive. And the second part is we actually execute the query. Notice how small that part is. It's just a one line of code. And the third part is we evaluate and understand what's going on, what has happened, and report to the higher level logic of the application what should be done next. Processing of the errors, for example. And let's focus on the second part, on the actual execution. There are three parts to it. There is input, output. Everything is passed as the dictionary. There is really no data types that are predefined in some way. And the only thing you get back is the error code. The way Keychain works is that you give it the pointer reference to the data that you want to be written to, and the Keychain writes the response to that specific pointer. And the error code you get is something like this. You can look it up. There's even the website called OS Status where you can get a meaningful, user-friendly description of this error. And let's fix this first. I would prefer to make this an object-oriented API so that I can have a Keychain object and I can get a method to understand what this error is all about. Fortunately, there is already a way to do that. In fact, if we pass just an OS status to a few methods, to system methods, we can get back the description of the error, and then we can wrap it into an NS error, which is interoperable with Swift errors, so it will make the API much, much better just from the stage one. And we just send this error back to the API that is later going to throw it or process it and so forth. And this is so much better already. If we just get the description, put it on, wrap it into error and give an error code and give it to the higher level logic to the caller. Now let's store some data. Before we begin the actual coding, we'll take a look at how it works and structured under the hood. The Keychain has really three parts to any data being stored there. So the first part is the service that defines that data. Service is something that is a Keychain terminology. This could be used to segregate multiple data pieces from each other. The other part is the account. That's again the Keychain term, but normally it's known as the key that identifies your data. And then there's value data. That is the Keychain term. This is the actual value or payload that you want to store. And of course, I said data. That means all of the data in the Keychain is stored only as the data. There is no strings, integers, booleans. It's always data. Now let's get back to the service. The service included with each request. So whenever we call, if we just use one service, we always have to put that string service in to request. And that's a bit annoying. So let's make a class that will keep that reference and store it for us and then populate to every request when we want it. So we create just a Keychain, we keep that reference, we initialize it with a service, and later we will use this service in every query. For that, we create some sort of a template of the query, which we've seen in the in the demo query that I've presented. We have this big configuration before we do anything with a Keychain, and this is one of those sample queries. It's really just a bunch of strings with values, so keys and values, or dictionary, if you will. And we put that service in already. So once we work with this query, we will add something else to the dictionary, and that's how we will configure the query. For example, the removing is actually simpler than adding or getting the data, and the removal would be the basic request. So simple as that. You get this template query, we copy it because it's a struct. We are just copying it. In Swift, referencing a struct in a new variable will just create a new copy. And then we add the key we want to delete and pass it to the delete method of the keychain, and then we process it with the error method that we just developed a few slides earlier. And setting is a bit more difficult. The first thing you want to do is to delete the key, because if you were to overwrite the key, well, Keychain can't overwrite the thing. It will throw you an error that you're trying to record a duplicate key. And you remove it first, but then you again use this base query and populate the keys and values. So the key, which means the account, and the value, which is the value data, and execute the add command. And again, error processing in the same way. We use the same method that we've just extracted. Getting the data is the most complex thing among all of them, and we again use the base query, and we use the method copy matching, because there might be more than one value matching your request, so keep that in mind. But for this, we are actually limiting. There is, if you check, there is match limit 1, very important. This will limit the search limit. How much do we want to actually search the keychain? As soon as it finds some of the value, it will return it to you. This will also increase the performance. And everything else is pretty much the same, error processing and returning of the data. But so far we have just two methods. It's getting and setting data, and removing, of course, the key. But the only thing you can get and set is the data. How we can go about the other types. And the other data types would be, of course, we can do this, transform any data type that could be written into the data. You can do this at the application level, and you can pass that into the keychain. That's one way, but it's not really convenient. User defaults, which is usually imitated by every keychain wrapper, has support for integers, numbers, booleans, strings, and we'll do the same thing. For example, that's right, a method to getting a string. We just use the data, and getting the data, we use the method for getting the data that we wrote earlier, and we just transform the data into string before returning it to the client. If there is any error, we just return nil and throw an error. The same applies, for example, for the NS number or number-like types, because NS number can be encoded into string. We can use that to now with our string method to support boolean, integer, double, and any value that could be converted to NS number and to a string respectively. But really, this is my choice. You can choose something else. This is up to you. And obviously, this is quite repetitive, and you will have to add this for every data type that you want to transform. Is there a generic approach? Of course there is. Another approach is codable, using codable. We just write one method instead, which is specialized over T, type T, and then we pass that type to the decode function instead of using a specific type. So this will add support for structs, integers, booleans, everything that we want, everything that's conforming to codable, custom types, everything you can shovel there in. This is the example usage. It's the only caveat: you need to specify the type you want to receive when you query data, because the compiler cannot know what you want to receive. It has to know the type in advance at the compile stage. Now let's get a bit more advanced topic, the keychain sharing. So the keychain sharing is when you share your keychain contents with multiple apps or app extension. That's really important right now, because a lot of the development is actually going not within the apps, but something outside the apps, like live activities or application extensions, widgets. Everything has to share data with the main app so that it looks cohesive and provides very cohesive experience for the end user. And let's get back to our diagram, to our schema. With the keychain sharing, it will look something like this. There are some components, some keys and values that are stored only within specific app, and there are some that are actually stored in a shared group, and everyone has access to those data. We start with no sharing. You need to go to Xcode settings, to the project file settings, and go to signing in capabilities, select that, and then add the new capability, and add an app group. I recommend app group, not the keychain group. We'll get back to that a bit later. And then you need to create one app group yourself. This is how it looks. And then you add a plus and create the app group. You name it something unique, and it will contain your bundle ID of your app, and will contain as well the group prefix. And then the group is ready. It will be looking like this. And before you can actually deploy your app, you need to register it in the App Store. Go to your certificates, identities, and profiles. Select app group and do the same thing. Just pop that group into that that field, and you're ready to go. Now we will have this structure. As we have seen earlier, all of those shared items will be available in the shared container. And the sharing is actually quite easy once you've set up the group. That's actually the most difficult part of the job. And we adjust our class a little bit. Now we have the app group also as the initializer and as the initializer parameter. And you use that app group also to every request. So that instead of writing in an application specific into an application contained or extension contained keychain, you'll be writing it to a shared keychain with that app group. This is how it looks. We just create an app group and pass that app group into every query. We just adjust our base query like this. It's very similar to a service. Now let's take a look at the use cases from a bit from real world. One of them, as I mentioned earlier, is sharing data with the extension. For example, this is a sample app for a password manager. It looks like this, and the user might select to unlock the app with the Face ID or biometry. That could be Touch ID, or if it's a vision, it would be a optic ID. Doesn't matter. It's the same API. And then in the extension, the user will be able to unlock that without enrolling again, without approving or entering a password, because usually the biometry protects the access to some key, right? And when you want to extract that key, you have to authenticate the user. But to put the key in, you need to know the key as well. So if you do not use the keychain sharing, the user will have to put that key in once in the app and once in the extension. With this design, you will be able to allow the user to put the key somewhere only in one place in the app, and then just move around, use multiple apps, and they will use this authentication or use an extension. It will just immediately authenticate your user the next time he uses it. And let's continue with our case studies. One of them is erasing data on the reinstallation. Keychain does not erase data on reinstallation. That's usually a pro and a con. For something, it's a con. You really want to erase your data once your app is reinstalled, because Keychain is used to store sensitive things, and lots of problems might happen with that. For example, you might persist your login information on the relaunch of the app. The user just reinstalled the app, installs again, and he's not logged out. Usually what people use for this kind of pattern is to put some key in user defaults and then check if that key is present. And if it's not present, it means that the keychain is to be deleted because the user just reinstalled the app. But that's not a really good approach because the data is still there and the data is still available. So the moment this code malfunctions, you will have some problems. It's really not a secure design, I would say. Apple understands that, they acknowledge that publicly on the forums, and their DTS engineer advised this. So you can effectively implement auto-delete feature by scrambling the contents of the keychain with some key that you stored in user defaults. And the next time the user installs the app, the user defaults is gone, and the data is gone because it's encrypted. Let's do this. Actually, sounds a bit more complicated, but in fact, it's really simple. We go back to our initializer, we adjust it again, and we put something like this. We have a scrambling key that has to be initialized on each keychain initialization, and we use it either from the user defaults or we create one. So if the key is available, that means that we are running normal operation. There is no reinstallation event in between the keychain initializations, and we just use this key further, and the data will be available with that key. It will be decrypted. But if there is no key available, we create a new one. This will create a new key for you, which is cryptographically secure. And since the user default is erased on reinstallation, your data is effectively gone once this happens. And the keychain is correctly erased, and there is really no way to recover this data after the app has been reinstalled. It's really future-proof because you don't have to keep track of those user default flags. And we just need to adjust the set and get methods as well. You don't need to adjust the remove methods, of course, because you just delete the data. Regardless, you don't need to know what you're deleting. And you just add a few more lines of code that will scramble and unscramble the code, the keys for you and the values. And that's it. And let's get back a bit more in detail on the biometrics, and specifically on the biometric protected keychain. So the big benefit of a biometrically protected keychain, so we earlier knew that we shared keychain, and now the biometric protected key shouldn't be entered more than once across the whole set of app and extensions. The benefit is that no access to data if the user is not authenticated with the biometry, obviously, but there is no access even to application itself, which is even more interesting because even, let's say, assume that the app is hacked in some way. The app cannot get the data itself. You have to really get the keychain and authorize the user with the biometry, and that's it. It's really well protected. So if there is an encryption key stored in a keychain protected by the biometry, you can't really get to it unless you, even if you have the access to the app, to its storage, to everything. And the values are erased when the biometry state changes. Let's say the user enrolls someone else's face or fingerprint, and that person now tries to unlock the key, the app with the fingerprint or with a face snapshot. It will fail because the key is not there. The user has to know the key again to enroll it. Let's try to implement this at the code level. It looks like this. I know it's lots of text and little font, but the most important thing is here we're just adding an attribute to our query again. Think about it, we just have the base query and we populate something in the moment we want to get or set something. And the most important part here is that this in-out parameter that allows us to just run the query through multiple of methods that modify the query in a certain way, and we will just write into the same query. We will not have to create a copy like normally with Swift. And we just need to add this this flag, this access control flag, and the flag is called when unlocked this device only with biometry. So we need to add this biometry current set. Accessible when unlocked this device only means that it will not be backed up to iCloud or Mac backups, and the biometric current set is actually doing the biometric protection. And then when you use it like that. When you get the key, you just append the attribute, and the keychain will then try to read the key if the biometry has been authorized at this specific stage. And yeah, this is how it looks like. The user the user enrolls the app, the biometric into the app, and then uses it in the app extension, as I said. And what's really interesting now, if you think about it, if the biometric signature changes, would you like to keep that information that the user actually wanted to use the biometry, but the app cannot use it now because the key is gone? The next time the user enters the password, it will be stored again, and the user will not have to press this toggle again to enable the biometry again. So yeah, of course that's possible. Let's detect this event of change of the biometric signature. Let's say we have normally working biometric app, and the user enters in another face scan. This is the the event of changed biometric signature, and then we keep the toggle, but the user won't be able to authenticate, and then the user will need to use the password for the authentication. The way I've achieved, there are really many ways to do that. The way I achieve it is by storing two keys. One of them is biometry enabled, so if we go back, that would be the key indicating this flag that the user toggled this in, this specific toggle, use Face ID to unlock in the app. And another one is the actual key that you want to store. So instead of one, you use two keys, and then you can get three values. One is the biometry not enabled when both keys are absent. Two, when the biometry is enabled and available, so the user can actually use something, use a face scan or a fingerprint to get to the protected data. And the third one, which we are interested in, is the biometric signature changed. That means when the actual key will be absent, but the flag will be present that the user earlier has enabled his choice, enabled the choice to go with the biometric authentication. It's just right now you cannot use the key, and you need to request it again from the user to continue to using the biometric authentication. Good. And that was biometrically protected keychain. And last thing I wanted to mention is the access control attributes. The biometric protection is not really an access control. It's not fitting in this group. These are more about when the keychain is accessible and not. And if we hide the repeat part, really there's three of these that persisted in backups. That's when passcode set this device only, when unlocked this device only, and after first unlock this device only. The default one is when unlocked, and just keep in mind that this is not accessible in the background. So if you're using Keychain to store data, configuration, and anything that changes how your app behaves, really think quite a lot about it and about the background execution, because this might cause trouble. The app might think the user is not logged in the background scenario, but it will work normally in the foreground. It creates many complex bugs. So again, one advice of checking out this new library that just dropped 1 week ago from Apple. It's called Swift Configuration. And to conclude, the Keychain has a very powerful API, and I recommend to use it in design different flows to improve your user experience. For example, no multiple biometric prompts like some authenticator apps do all the time. They prompt you like 3 times to just get one number. You know why now? The automatic data erasure, that when the user deletes the app, the data is gone as well, and it's secure, and seamless sharing of the data between multiple apps and extensions. So it takes an effort to develop secure code, but the Keychain not only can help you with that, but it can actually elevate your apps and extensions user experience. Thank you so much. This is my contact info. Feel free to contact me or post your questions through the SwiftLeeds platform, and I will be answering every Keychain related question in the Slack. Thank you so much.